Hey guys, welcome to Smart Intelligence YouTube channel. I'm Vinay. In this video, we are going to discuss Codechef Starters 147, Division 3 third problem. The problem name is non-primes 101. So the problem statement is, you are given an array A of size n and you have to find the page I comma j such that A of I plus A of j is not a prime number. And they also mentioned that the indices are one-based indexing. In case of multiple I comma j pairs are valid, you can print any one. If it is impossible to find such pairs, just print -1. So a prime number is nothing but it has exactly two positive divisors, 1 and x itself. So you're given input format, t test cases, and size of an array and array elements. So the output format is, if there exists any valid pair, you have to print that pair. Otherwise, you have to print -1. So if there are multiple pairs valid, you can print any one of the pairs. And if you observe the constraints, t can go up to 10 to the power of 4, and n can go up to 2 to 10 to the power of 5, and array elements are in the range 1 to 100. So how can you solve it? What's a very basic brute force approach to solve this? So the brute force approach is nothing but we can generate all the bits. The first approach, we can generate all the bits and check if the pair is valid or not. Check if pair is valid. If the pair is valid, then we can simply print that pair. And after generating all the pairs, if there is no valid pair, print -1. How can you write the code for this? Simply, how to generate all the pairs? How can we generate all the pairs? With using two for loops. The outer for loop will iterate from I equal to 0, I less than n, where n is the size of an array, and I plus plus. And the inner for loop will iterate from j equals to I plus 1, and j less than n, and j plus plus. So we'll check the valid condition. If valid, a of I comma a of j, if they are valid, then we'll print I plus 1 comma j plus 1, because we need to print the output one-based indexing. If you see the sample input for the four test cases, for the first test case, 3 plus 6 is nothing but 9, which is not a prime number. So we have printed 1 comma 2 because one indexing. And if you take 1, 2, 3, 4, if you take 1 and 2, you'll get 3, which is a prime number, not a valid. If you take 1 and 3, you'll get 4, which is not a prime number. So we can print 1 comma 3. Index, it is not the values, they are the one-based indices. And for the third test case, if you take 1 plus 1, you'll get 2, which is prime numbers. 1 plus 2, which is 3 prime numbers, and 1 plus 2, which is prime numbers. So there is no valid pairs. So we will print -1 here. So for the last test case, 3 plus 2 will get 5, which is a prime number. 3 plus 3, which is 6, which is not a prime number. Nothing but we can print either 1 comma 3 or 3 comma 1. Anything is fine. So moving to the brute force solution, we can generate all the pairs and check the valid condition. If it is valid, simply print the indices and break. Now, if it is not a valid pair, you need to print -1, then how will you know that? How will you know that it is not a valid pair? I will maintain a variable nothing but whether the valid pair is found or not. Initially, I will initialize found to false. Denotes that I have not found the valid pair. Once I found the valid pair, I will initialize found to 0. Sorry, found to true, and I will break the loop. So when you write the break statement here, it will only break this inner for loop, but still it will keep on iterating the outer for loop. So how can we also break this outer for loop? So once you found the page, once you found the valid page, after this for loop, again you have to check the condition. If found is true, nothing but if you have found the valid page, you have to break again. You have to break it. So how do you know that you have not found the valid page? After this outer for loop, if found is equals to false, that means I have not found any valid page. So I will print -1 here. I will print -1 here. So this is a brute force approach. Now tell me, what's the time and space complexity? This will iterate for n times, and this will iterate for n times. And for the valid condition, how much time do you think it will take? So valid is nothing but you have to check whether the sum of a of I plus a of j is not a prime number. Is not a prime number. If we write the simple is prime function, let's say I have is prime function. We'll write here. So if I have is prime function, I hope everyone know how to write the is prime function. If not, let's see. So I'll pass an element n. So we have to return true or false. If n equals to n is less than or equals to 1, simply return false. It is not a prime number. If n equals to 2 or n equals to 3, we can simply return true. Else, I'll iterate for loop int I equals to 2, where I into I is less than or equals to n I plus plus. And I'll check if n is divisible by 2, then it is not a prime number. Return false. After iterating over all the elements, if it is not divisible by I, it is not divisible by I, then we'll return true. So this is how our is prime function looks like. And the time complexity of this is prime function is n. It will take root n. So now, if we calculate the time complexity of our approach, it will take root n. So instead of calling valid, I will call not of is prime. Not of is prime. So I will pass a of I plus a of j to this is prime function. If it is a prime number, I'm checking not condition. If it is not a prime, then it will become true. Then I'm printing their indices and I'm making found equals to true. I'm breaking it. So the time complexity is n into root n. So we know that if you check the constraints, n can go up to 10 power 5. N can go up to 10 power 5. If you substitute here, you'll get 10 power 5 into 10 power 5 into root 10 power 5, which will exceed the number of iterations limit. If the number of iterations is exceeding 10 to the power of 8, you'll get time limit exceeded. So obviously you'll get time limit exceeded here. How can we optimize this? What are the things are possible to optimize this? So if you observe 𝗍' function here, if you check the constraints, before that, if you check the constraints, the array elements are ranging from 1 to 100. The array elements are ranging from 1 to 100. So if you take what will be the minimum and the maximum value of this a of I plus a of g? Minimum and the maximum of a of I plus a of g. If we assume the least values in the range 1 to 100, let us assume 1 comma 1. So a of I is 1 and a of j is 1. So the minimum value will be 2. And what's the maximum value it can go up to a of I plus a of j? 100 plus 100. You'll get 200 here. The maximum value will be 200. So if you observe here, instead of checking the prime function for each number, can we pre-compute all the prime values from 2 to 200? If we pre-compute all the prime values from 2 to 200, to check this 𝗍' function, it will be computed in big O of 1 time. Big O of 1 time. So before entering into this, executing this, you will generate all the possibilities. All the possible, generate all valid prime numbers from 2 to 200. How much time will it take? How much time it will take? It will be done in constant time, because to generate one, to check a given number is prime or not, how much time will it take? Root n. So totally we have only 200 elements. So 200 into under root 200. Right? So it will be done in constant time. So after this, here we can reduce the time complexity from root n to big O of n. So what will be the time complexity now? If you pre-compute the prime numbers, the time complexity will be n into n. If you substitute n equals to 10 power 5, still it is greater than or equals to 10 to the power of 8. Still it is greater, which is exceeding the limit. So even though if we optimize the primes, it will give you TL. So we understood that if we are generating all the pairs, then definitely it is taking 10 power 10 iterations. If you are generating all the pairs, definitely it is taking 10 power 10 iterations. So the thing is, we have to optimize generating the pairs. We have to optimize generating all the pairs. Okay, let's see how can we optimize it. So we know that A is ranging from 1 to 100, right? Okay, so what I'll do is, I'll take an array. It is of size 1000. It is of size 1000. Let's say I have elements 1, 2, 3, 4, 5, up to 100. After 100, 100 is repeating for the remaining 900 times. For the remaining 900 times, my 100 is repeating. So now, if you observe carefully, while generating the pairs, I'll check 1 with 2, 1 with 3, 1 with 4, 1 with 5, 1 with 100, 1 with 100 again, 1 with 100 again. Like that, even though we know that if 1 comma 100 is valid or invalid, no need to check with again 1 with 100, right? Again, no need to check with 1 with 100. So if we observe here, Can I skip all these iterations? If I done with 1 with 100, can I ignore 1 with 100 again? I can skip 900 pairs now. With 1, I can skip 900 pairs. With 2, 900 pairs. With 3, 900 pairs. With 4, 900 pairs. If we get the distinct elements from the array, we can reduce the generating number of all the pairs. So we know that array elements will be ranging from 1 to 100. Array elements range. But the size of arrays can go up to 10 power 5. But once you compute count array for the given array, I hope you guys know count array. Count array is nothing but if you're having the elements, let's say I'll take my count array. This array have the indices from 0 to 100 because my elements ranging from 1 to 100. So maximum range is 100. So I'm taking 0 to 100. What will be the size of the count array? 101. So now what I'll do is initially the count array will have zeros. That means for each index will have 0. That means 1 is repeating 0 times. Initially all 0. So I will iterate over this array. I found 1. I'll go to this index. I'll increment the count. I'll go to the next element 2. I'll go to 2 index. I'll increment the count. I'll go to 3, increment the count. For 4, go to 4 index, increment the count. And so on. For 100, I'll go to 100 index, I'll increment the count. So for 100 again, I'll go to 100, increment the count. Like this, it will go up to 900. 100 is repeating for 900 times. So now, what's the size of my count array? 101. So now, if you have this count array, can you reduce checking all the repeated pairs? Here I'm checking 1 with 100, 1 with 100 again. So instead of that, if you have the count array, can you check? I will check the pairs 1 with 2, 1 with 3, 1 with 4, 1 with 5. Let's say 5 is not present in the above array. Let's say 5 is not present in the above array. So if 5 is not present, so do I need to check 1 with 5? Do I need to check whether 1, 5 is a valid pair? Not required, because the element is not present in the array. So we no need to check 1 with 5 if their counts are greater than 0. Cool. It is clear. Okay, I'll take a small example. I'll start from 1. I'll check the pair with 1 and 2. If it is a valid pair, then what I'll do? I need to print the indices. I should not print the elements. Once I'll generate 1, 2. If it is both are greater than 0, that means frequencies are greater than 0. That means they are occurring in the array. They are present in the array. So I can check 1 with 2. If they are valid pairs, so what I will do? I will get the index of 1 and index of 2 from the above array and print their indices. So it is a valid pair with 1, 2. 1 plus 2 is a 3, which is not a valid. So what I'll do? I'll check 1 with 3. 1 plus 3 is nothing but 4. Is 4 a valid pair? Yes, 4 is a non-prime number, so it is a valid pair. So we have to get the index of 1, and we have to get the index of 3, and we have to print it. So what's the index of 1 in the above array? It is 0, but given the 1 based indexing. So we have to print 1, 3 index is 3. So we have to print 1 comma. How many maximum pairs will get from this comma? 100 into 100 plus 1 by 2. Simple. How many pairs you'll have? In the above array, if you're having array of size n, you're having n square pairs. You're having n square pairs. These two for loops will generate n square pairs, where n is 10 power 5. But if you observe here, how many pairs will get here? 100 into 100 pairs at max. 100 into 100 pairs. So for each pair, what operations we are doing? For each pair, what operations we are doing? Okay, first let's try write the code for generating the pairs. So for int I equals to 0, is it 0 or 1? We are checking the based on indices 1 to 100. I plus plus, and the inner for loop int j equals to I plus, we can start from I j less than or equals to 100 and j plus plus. And we have to check 1 with 2, 1 with 3, 1 with 4, 1 with 5, and so on. If it is a valid pair, then we'll print it. But what if I have only tens in the array? I have only tens. So all my frequencies will be 0 here, 0, 0. So you'll have 10 is repeating for 6 times. Now, how many valid pairs we can generate here? Actually, if you observe here, what we are doing, we are taking 1 and we are checking the elements are not present in the array. So we'll skip it. Take 2. 2 is not present in the array. We'll take 3. 3 is not present in the array. We'll take 4. 4 is not present. 5 not present. 10 present. But with 10, we are checking with 11, 12, 13 up to 100. But we don't have any elements. 11, 12, we don't have any other elements. But still there exists a pair in the array. In the array 10, 10, the sum is 20, which is not a prime number. So it is a valid pair. But how can I check here? How can I check here? So before that, we have only checking the 1 and 2, 1 and 3, 1 and 4, 1 and 5, 2, 3, 2, 4, 2, 5, and so on. But if 4 is repeating for 2 times, can't I say that it is a valid pair? It is a valid pair. It's a valid pair, right? So we also need to check if the frequency is 1, then there are no valid pairs. So we can print -1. But if the frequency is 2, then there is a valid pair. So for equal elements as well, we have to check whether they are valid or not. So that's the reason I'm starting j equals to I here. Instead of starting j equals to I plus 1, I'm starting j equals to I. So what's the first condition we have to check? If count array of I is greater than 0 and count array of j is greater than 0. That means these elements are present in the array. We will make sure that I and j are present in the array. If they are present in the array, then the frequency will be greater than 0. So moving forward, once they are present in the array, we have to check the valid condition. So what the valid condition we have to check? If, again there are two possibilities. The first possibility is we have to make sure if I is not equals to j, if I is not equals to j, and is not a prime number, I'll call the is prime function with I plus j. If I is not equals to j and I plus j is not a prime number, that means it is a valid pair. So I will print index of I from the array. I need to print index of I from the array. So simply I'm writing array.index of I. Let us assume that it will return the index of I in the given array in the array. And we also need plus 1. We need to add plus 1 because it is 1 based indexing. And I'm writing array.index of j plus 1. So this is how we can print the indices. And once you found the valid pair, we'll make found equals to true. So before here we have to declare here found equals to false initial. And once you found it, simply break it. So this is a condition if I is not equals to j. But there is also case that we also need to check the case for I is equals to j. So we have to check if I is equals to j. What do you need to check? The frequency should be greater than 1, greater than or equals to 2. And counter of I is greater than 2. Then what we can do? We can print AR dot first index of I plus 1 comma AR dot second index of I plus 1 and make found equals to true and break it. And we'll break it. So once you break this inner for loop, we'll check the condition if found, break the outer for loop. After the outer for loop, if found is equals to false, that means we have not found any valid pair, print -1. We have to print the -1. I hope the code is clear. So what's the time complexity? It can go up to 100 iterations. This can go up to 100 iterations at max. And here we're checking is prime. It will assume it will take root n time. And we also need to check one more condition here. Valid condition. Is prime should be false. Is prime of I plus I. If it is false, then we can print the pairs. Simple. So this function will take in root n time. So overall, this sum will not exceed 200 at max. Root 200. It can go up to 100 into under root 200 plus under root 200. Why plus? Because this is root 200 plus this is root 200. They are not inside it. They are parallel to each other. So number of iterations are less than 10 power 8, which will not give you the time complexity. TL. Okay, let's try to implement this code. Okay, we are having, so here, first, read the t number of test cases. Size of the array and read the array elements. So after reading the array elements, we have to generate a counter. What is the size of the counter? Will initialize 0 initially. So we have declared 101 because we want to access 100 index. So the size of the counter is 101. So generate the counter array of array of 5 plus 1. So now before that, okay, we'll move forward. So now we have to declare a variable called found, which is initially initialized to false. That means no valid pair is found. So now I will iterate a loop from 1 to 101 because 101 is excluding index, and for j in range I comma 101. So what a condition we have to check initially, if count array of I is greater than 0 and count array of j is greater than 0. If greater than 0 defines that the elements are present in the array. If the elements are present in the array, what do we need to check? We have to check the next condition. If I is not equals to j and is prime, we'll write the is prime function later. If I plus j is not, if it is returning false, then we have to print the array dot index of I comma array dot index of j. Similarly, it will return the index of the I and j element. And we have to make found equals to true, and we have to break it. This is the first condition. If I is not equals to j. If I is equals to j, what we have to check? We have to check two conditions. Count array of I should be greater than 1 and I plus I should be a not prime. So I'll call is prime function again. I plus I. If it is returning false, then print array dot. I'll write this function later. First, assume that this will return the first index of I, comma array dot second index of I. After printing it, we have to make found equals to true and break it. So after the inner for loop, we have to check if found is true, then we have to break the outer for loop. After the outer for loop, if found is false, then we have to print -1. So we have to implement few functions. Is prime function first. Is prime. So it will take n, and we have if n is less than or equals to 1, we'll simply return false. If n is equals to 2 or n is equals to 3, we'll return true. Otherwise, we'll iterate a for loop from 2 to n by 2 plus 1. If n mod I is equals to 0, that means it is not a prime number. Simply return false. Otherwise, return true. and we are done with each prime function, and we have to write this first index and second index. So how much time will it take? It will take n time. So I'll iterate for I in range n. Evaluate the function definition first index. Okay, we'll pass the parameters. So instead of writing array.index, we'll call the first index with array and I. Second index of array comma I. So for the first index, the parameters are array and I. So I'll take array comma key. So I'll check get the length of array. For I in range n, I'll check if array of I is equals to k, then simply return I. Simply return I. Done with first index, and we have to print second index array comma k. N equals to length of array. For I in range, maintain a count c equals to 0. When the occurrence of second element, we have to return that index. So if array of I is equals to k, simply increment the count. If count is equals to 2, simply return ith index. Nothing but that element is repeating for 2 times. We have to return the second occurrence of that index. And we have, it is a one based indexing. We have to print array dot index plus 1 and array dot index of j plus 1. Same here as well. Plus 1 and plus 1. Okay, let's run it. It is not t, we have to read the input. It doesn't matter 1, 3 or 3, 1. That's it. So we did not get any DLA because we are iterating over only 100 into 100 iterations. That's it. The code is successfully get submitted. And if you're interested in programming and want to become a good problem solver, we have a 3 months long course to master data structures and algorithms. For more information, you can click on the link in the description. And if you like the video, consider liking it and subscribe for more such content. That's it for this video, and have a great day.